In today's class, we will discuss exercise 3.1, question number 1 to question number 4. Hello everyone, I am Payel and welcome back to my channel Ganit Mathematics Classes. So, first we will start number 1. Given, here are some figures. Classify each of them on the basis of the following. Number A is simple curve, number B simple closed curve, number C polygon, number D convex polygon, and number E is concave polygon. Okay, here are given some figures. Okay, so from here we have to choose. Number A is a simple curve. Okay, now see number 1. It is a simple curve. Okay, so number 1. Now number 2. Number 2, it is also a simple curve. So number 2. Now come to number 3. See, number 3 is a first inside a circle, outside also it is a circle. So here it is 2 circles. Okay, so it is not a simple curve. Next one is 4. 4 is a star and we can see there are intersection of lines are there. So it is not a simple curve. Come to number 5. It is made up of curved line and it is a simple figure. So number 5. Number 6. It is also a simple, okay, it is made up of line segment and curved line, so it is a simple curve. Number 7 also, it is made up of line segment and curved line, so it is a simple figure. Number 8, see, 2 circles are or oval shaped structure is there and then it is joined with a line. Okay, so it is not a simple. Okay, so next to the number B. Simple closed curve. It should be simple and it is a closed curve. Okay. Number 1, it is simple. First we have to consider all the simple curves that we have just taken out and from them we have to see it is simple, closed or not. Okay. See, simple curve is number 1. Okay, it is closed. So number 1 will come here. Then number 2 is also a simple curve. It is closed or not? Yes, it is closed. So it will come here. Next is simple curve is number 5. Number 5 is also closed. So yes, we will write it down. Next, number 6 is simple curve and it is a closed curve also. So number 6. Number 7 is also a simple curve and it is closed also. So we will write number 7. Okay. Next, number C is a polygon. What is the definition of polygon? It should be a simple closed curve made up of only line segment. So from here only we can choose. Number 1. Is it made up of only line segment? Yes. So number 1. Number 2 is a simple closed curve. Is it made up of only line segment? Yes. So number 2 also will go with it. Now number 5. Number 5 is not made up of line segment. So no, it will not go. Similarly number C, curved line is there. So no, cancel it out. Now number 7 also here curved line is there. So it will not go with it. Okay, so what are the polygons here? Number 1 and number 2 are the polygons here. Now come to number D, convex polygon. Okay, now it should be a polygon. So 1 and 2 are polygons here. Now what is convex? All the angles should be less than 180 degree. Okay, first check it. See here, okay, all the angles are less than 180 degree, but we have to check this angle. Or it is a cave-like structure is there. So similarly here we can say it is not a convex figure. It is a concave, cave-like structure is there. Okay, and this angle is also more than 180 degree. So it is not a convex figure. Now come to number 2. In number 2 all the angles are less than 180 degree. So this is a convex figure. So number 2. Now number E is what? Concave polygon. So it is just we have discussed. Number 1 is concave polygon. Okay. In this way, we have to find them out. Hope you have understood this. Now come to number 2. How many diagonals does each of the following have? A convex quadrilateral. Number A. So first we have drawn a convex quadrilateral here. It is very easy to draw. A, B, C, D. We have named it as A, B, C, D. Now how to draw the diagonals? Just we have to join the non-consecutive vertices. So if we consider the point A or vertex A, what is the non-consecutive vertex? It is C. So just we will join them. Okay. Then if you consider B, then B will be the non-consecutive, so we will join them. Okay. So here we have got two diagonals for this quadrilateral. Okay, so we will write it down, two diagonals for this quadrilateral. Next is a regular hexagon. So first we will name it out P, Q, R, S, T, U. Okay, we have named it, and now we will start drawing the diagonals. First we will consider the vertex P. P and Q are, we can't join them, P and R. P and R. First diagonal P and S, we can join P and S. Then P and T also we can join. So how many diagonals we have got? 3. So here we will write down 3 plus. Next come to the vertex Q. With Q, R is already joined, and Q and S we will join. Q and S 1, Q and T 2, Q and U 3. So here also we have got 3 diagonals plus. Next come to the vertex R. R and P is already joined. Now we will join R and U 1 and R and T 2. So we have joined 2 diagonals. Okay, plus. Next is S. With S, other 2 points are already joined. Now we will join S and U. S and U. Okay, so S and U, SP, SQ. So we have already joined them. So here we have got only 1. Okay, now with the vertex T, all the non-consecutive vertices are already joined. Similarly, with the vertex U, all the non-consecutive vertices are already joined. Okay, so here how many diagonals we have got? Here we have got 3 plus 3, 6 plus 2, 8 plus 1, 9. So we have got 9 diagonals for a regular hexagon. Okay, now for a triangle, we have already discussed it that in a triangle there is no non-consecutive vertices. So that's why we can't draw any diagonal over here. Okay, see A and B, these are continuous, so consecutive. B and C are also continuous and consecutive. A and C also continuous and consecutive. So we can't draw any diagonals for a triangle. So how many diagonals is there in a triangle? 0. Okay. So hope you have understood this. Next move to the question number 3. What is the sum of measures of angles of a convex quadrilateral? Will this property hold if the quadrilateral is not convex? Make a non-convex quadrilateral and try. Okay. So first of all, we have to draw a convex quadrilateral. Convex quadrilateral means what? All the angles should be less than 180 degree. See, this is a convex quadrilateral. A, B, C and D. Okay. Now from angle sum property of a quadrilateral, we can say that, or we have already proved that in our previous video. You can check it out. Here I will put the link, and I will give the link in the description also. You can check how we have proved that the angle sum property of a quadrilateral. So from there we can say that this sum of all the angles of this convex quadrilateral is equals to 360 degree. Okay. So we will write the sum of all the angles of a convex quadrilateral is 360 degree. Or just you can divide the triangles and if I add these triangles, you will get 360 degree. That means the sum of all the angles is equals to 360 degree. Now, next part is what? Will this property hold if the quadrilateral is not convex? Now we have to draw a concave polygon. Now, not convex means it is a concave polygon. Okay. Now see here we have made a concave polygon P, Q, R and S. See here this angle is more than 180 degree. This angle is more than 180 degree and all the other angles are less than 180 degree. Okay. Now similarly if you draw a diagonal here, you just divided this quadrilateral into two triangles. Okay. Now from this triangle PSR, what you will get that sum of the angles of this triangle is equals to 180 degree. Okay. Now from this triangle PQR, what you will get that sum of all the angles of this triangle is 180 degree. Now this triangle plus this triangle is the whole quadrilateral PQRS. That means 180 degree plus 180 degree is equals to 360 degree. Okay, that means yes, this property hold for a non-convex polygon or a concave polygon also. Okay, so this is the answer of your question number 3. Now come to question number 4. Examine the table. Each figure is divided into triangles and sum of the angles deduced from that. Okay, here in this question we will get a formula. Okay, so what formula we will get? Let us check. So figure a triangle is given here. Okay, now how many sides is there? 3 sides and angle sum is 180 degree. This we know that sum of all the angles of a triangle is 180 degree. Okay, now here it's 4 vertices means a quadrilateral. Okay, 4 vertices and 4 sides is also there in a quadrilateral. Now by joining or by drawing a diagonal, it is divided into 2 triangles. Okay, now what it is given angle sum 2 multiplied by 180 degree. Just we have discussed in question number 3 that this triangle, this is also triangle and the sum of all the angles in this triangle is 180 degree and sum of all the angles in this triangle is also 180 degree. So 2 triangles, no? So 2 multiplied by 180 degree. Okay, this is the sum of all the angles, that is 360 degree. Okay, how we can represent it? 4 minus 2 multiplied by 180 degree. We can represent this in this way also. 4 minus 2. Here 4. What is 4? 4 is number of sides. Number of sides is 4 minus 2 into 180 degree. Okay. So here by using this we can get angle sum of this quadrilateral. Now here see 5 vertices are there. It is a pentagon. Okay. Now by drawing 2 diagonals, they have divided this pentagon into 3 triangles. Okay. So what is the angle sum of this pentagon? 3 multiplied by 180 degree. Okay. Why 3 multiplied by 180 degree? Because 3 triangles are there and in each triangle sum of all the angles is equals to 180 degree. So that's why 3 multiplied by 180 degree. Okay. Now how we can represent it? How many sides are there in a pentagon? 5 sides. So how to write it? 5 minus 2 into 180 degree. By writing this also, we can find out angle sum of this pentagon. Okay. Now next one is a hexagon, and in this hexagon they have drawn 3 diagonals. By drawing 3 diagonals, they have divided this hexagon into 4 triangles. 1, 2, 3 and 4. Okay, 4 triangles. So how to take out angle sum? 4 multiplied by 180 degree. Yes. Now 4 multiplied by 180 degree, how we can write it? 6 minus 2. 6 means the total number of sides in a hexagon is 6 minus 2 into 180 degree. Okay. So from here what we can say that angle sum of a polygon equals to n minus 2 into 180 degree, where n is the number of sides. Yes, from this table we can conclude this. So from this table we can conclude that angle sum of a polygon, any polygon, okay, n minus 2 into 180 degree. Now what is n? N means number of sides of that particular polygon. Okay. Now see what you can say about the angle sum of a convex polygon with number of sides. See here number of sides are given. Here we have to find out angle sum. Okay. Now by using this formula we will find it out. Okay. Okay. Number A, number of sides is n equals to 7. It is given. Okay. Now angle sum equals to, what is the formula? N minus 2 multiplied by 180 degree. Okay. So 7 minus 2 into 180 degree. So 5 multiplied by 180 degree. 5 multiplied by 180 degree is what? 900 degree. Okay. So similarly number B it is given number of sides is 8. So number of sides, that means n equals to 8. So simply we will find it out by using the formula. Angle sum equals to 8 minus 2 multiplied by 180 degree. 6 multiplied by 180 degree. Okay. Now 6 multiplied by 18 is 108 and 0 is there. So 1080 degree. Okay. So now we will do number C. Number C, number of sides n equal to 10. So therefore angle sum equals to n minus 2 into 180 degree. So 10 minus 2 into 180 degree. That means 8 multiplied by 180 degree. And 8 multiplied by 18 is how much? 144. And 0 is there. So 440 degree. And the number D is that number of side is n. So this can be hold for number D. Where n is the number of sides, the angle sum of the polygon will be n minus 2 into 180 degree. Okay. Now see, you will remember this formula. In exam, you will get direct question. In this kind of tables will be not provided to you. Okay. So better you will remember this formula and you will use it in your sums to solve them. Hope you have understood this. So we will end our class here only. If you are new to my channel, please do subscribe to my channel and hit the bell icon to get all the notifications. In our next video, we will discuss other questions of this exercise. Thank you.